Hi, I'm Alex Lamb, author of the Roboteer science fiction novels, and you're watching Secrets of the Universe, the exciting video sequence in which I attempt quixotically to answer every single major scientific question that has ever been asked. Today, I want to talk about the Big Bang. What is the Big Bang? Big Bang is the notional start of everything. All of the things starting in that one thing. Why is it interesting? Well, why shouldn't it be interesting? This is how everything begins. This is how the whole universe notionally starts. That's got to be interesting. That's the origin of everything. I would think that's kind of cool. Also, I personally find it interesting because so many people get it wrong. This is something that's been out in the public domain and people have been thinking about it for decades now. And still there's a huge amount of I don't know, ambiguity, waffliness, just sheer confusion about what the Big Bang represents at some level. So hopefully in this video I'm going to try to, at least with regards to my own entirely subjective vision of it, clarify matters. Anyway, so that's that. So then there's a question of how does it work then? You know, I've said that people get it wrong. Well, what is a Big Bang actually like? Well, I can tell you what it's not like. The first thing to say it's not like is it's not like the way it normally gets depicted on TV, which is where you start off with a single point of bright light and then a physical explosion at which stuff roars out and expands into a space. That's not it. That leads to people asking all kinds of questions like, well, what was outside the universe before it started? And the answer is no, it doesn't work like that. And also, where's the middle of the universe? Where's the center of the explosion? Also, there is no middle. This is another thing. So that depiction that you see on TV, that is one where people have done their best to try to describe something that requires an extra dimension in order for you to picture it. Now, there's another popular vision that gets busted out sometimes by scientists, which I also don't like. And that is the idea of the infinite fruitcake. And the idea is you start off with a terribly dense fruitcake in the oven that you've filled up with nuts and fruit. Why you would do this, particularly with an infinite fruitcake, someone that you need an infinite oven to put it in, you turn the heat up to 450, and then as the fruitcake expands, what happens is all of the raisins and the nuts get further away from each other, but they're all expanding away from each other at the same time. Now this is much better, but it invokes a physical infinity, and as such is an unscientific description. There's no evidence of infinities anywhere. That's a kind of a problematic description of the Big Bang, if you like. My favorite one is what I recall the Batman model of the Big Bang. So the way in which the Batman model works is if first of all you imagine all the great and good of Gotham City, and you imagine them standing round in a ballroom, and it's not a terribly large ballroom. It's the large one got burnt down in a prior Joker event. So they're squeezed together in a relatively small ballroom. They're all sipping champagne and eating canapes and what have you. But then the evil villains of Gotham, they're at it again. So the first thing that happens is the Riddler runs up and puts teleport panels on the doors. And there's doors on every side of the building. There's even a skylight and a hole to get through to the basement. So he maps the basement to the skylight. So if you climb out of the top of the building, you're coming in through the bottom. He maps the north door to the south door. So you walk out through the north and you're coming in through the south. And the same with east to west. So there's just no way out of the ballroom. Everywhere you go, you're coming back into the same room. Ah, curse you, Riddler, you nutcase. And then what happens is the Joker has also set up shrink rays positioned in the top corners of the ballroom, so that what happens is that all of the people in the ballroom suddenly start to get smaller and smaller, so they can see through the doors and they can see each other, and there's like, oh, suddenly the gaps between them are getting enormous, but everybody's shrinking at the same time. So they're left with this existential quandary. Are they shrinking, or is the ballroom growing? And of course, this is the Joker's point. It's really unclear under these circumstances. The Joker is obviously, in this particular instance, a frustrated closet physicist. But the idea is that we can't really tell. What we're seeing is the ratio of the stuff to the gaps between the stuff that's changing, but it's really unclear to say whether or not the stuff that's in space is shrinking or the space itself that is growing. Now, we handily decide to explain it in terms of space growing, and that makes more sense than us. But there's not some magic center to the boron. The boron isn't exploding from anywhere. It's the ratio between the things and the gaps between the things that is changing over time. So that, I think, if you want a decent description of what the Big Bang was like, that gives you a better picture, at least to my mind. There's also the question of is it really the start? There are certain scientific approaches which propose that the Big Bang wasn't actually really the beginning of things, that maybe there was a big bounce instead, and there was a universe and it collapsed and then expanded out again. And the reason why it looks to us like there was a Big Bang is because the previous universe squidged inwards. I don't buy that. I think that's unnecessary complication. Another version is one where they invoke what's called an inflaton field, and they imagine an infinite universe. This is where the infinite fruitcake comes from. And basically that certain parts of this infinite universe at certain times happen to sort of like change state. They go from a kind of an infinite energy state to a finite energy state and then expand outwards into a, if you like, something like our universe, but that being our universe is just a pocket in a vast, infinite, ever-timeless inflaton field. I say bollocks. And why I say that is because that invokes such a large number of infinities and involves such a vast quantity of hand-wavium that it seems to me to be surely we must be able to do better, ladies and gentlemen. And so, is it the beginning of things? Well, I would say yes. And the reason why I would say yes is the version of physics which I personally think shows the greatest degree of promise, and that is the one of the discretization of space-time. And this is something that people have invoked not just sort of gleeful amateurs such as myself. There is the causal set program, which is a very wonderful, exciting field of quantum gravity research. There's also new ideas that are coming up to do with space-time modeled by networks of entanglement, a variety of different fields, all converging onto a similar concept. And that concept is that space-time is made up of a network of tiny little sort of units, if you like, or if you prefer to think of it another way, sort of like 3D pixels, voxels, if you like, mini chunks connected together in some interesting and fluid, bizarre fashion. And from my own modeling and from my own experimentation, one thing that I have noticed is that if you want to try to build a universe from scratch and you use discrete space-time, what you find is you have to have a Big Bang. You've got to have it there, because otherwise you don't get the nice, smooth, sort of like spacey, manifoldy sort of environment that we live in. If you don't start from a seed, you end up with some kind of non-dimensional squidge, which doesn't make a tremendous amount of sense. So to my mind, the Big Bang is an enormous clue. It tells us something about the kind of physical theories that are most likely to be correct. So rather than asking the question of like, well, what happened before though? Really, what we should be looking at is the fact that time itself, the whole idea of before, is itself a product of the structure of the universe. There is no before the Big Bang, because the Big Bang is, if you like, the beginning of the sequence of steps, the expansion, if you like, literally and mathematically, that defines the universe in which we live. Super! Anyway, that's my personal take on the Big Bang. Thank you very much for listening and watching. Next time, something else. Hooray! Bye!